Now it is time to take the plunge into actual sound design. And we're starting with the oscillator. Now, the oscillator is the source of audio generation in pretty much any synthesizer. It can be applied in different ways. There are digital synths like Massive. There are hardware analog synths. There's sample-based engines. But the principle is the same in each of these. You have an audio source, which in Massive, in this case, is represented as digital samples of waveforms. And that is what we start with when generating a sound. So if you open up a new sound in Massive, it sounds like that. Okay, so let's talk about what's happening now. We have only oscillator 1 activated. As you can see, oscillators 2 and 3 are both deactivated with the gray circle there. So we're dealing only with oscillator number 1. Up here in the top, there is a drop-down menu in which you can select a wave table. So when I click here, it pulls up these 5 different columns: virtual analog, basic, analog, electric, digital hybrid, and chords. These are different categories of wavetable. So what is a wavetable? Well, you can think of it as a two-dimensional digital sample. On the horizontal axis, left to right, is the actual wave. When it reaches the end of its cycle, it goes back to the beginning. So that's our left to right. When you're talking about up and down, you have the wavetable position. So each of these selections here in the wavetable have at least 2 different waveform readouts, and you can think of them as being sort of stacked on top of each other. So, and then in between those 2 waveforms are any number of intermediary waveforms, like a morphing between the 2 together. So here the default is square and saw 1. That means there's a square wave on the bottom of the stack, and on the top of the stack is a sawtooth wave. And then in between the 2 is any number of those morphed versions between the 2, between the square wave and the sawtooth wave. So let's listen. That's a sawtooth wave. It looks like the tooths on a saw that you cut wood with. Whoever named these waveforms did so in a way that sort of makes sense for how they actually look. So the sawtooth wave will go straight down at an angle and then straight up. It sounds kind of buzzy and full and classically analog. Like that. That is the source of a lot of cool lead sounds, and we'll talk more about that later, how that works. A square wave, on the other hand, if you pull the knob all the way to the left, so now we are selecting a square wave at the bottom of the stack. It's still buzzy, but it has a little bit more fullness to it. A square wave looks like squares, sort of like tables that the waveform goes straight up, across, and then straight down. That's a square wave. Now I can move my wavetable position knob in between the morphings of that stack. And so from the square wave all the way to the sawtooth wave and everything in between. So you can hear it blending in between those 2 different kinds of sounds. In analog synthesis, there are 4 basic waveforms. There's the sawtooth wave that we mentioned, this one. There's a square wave, still buzzy, but has a little bit of belliness to it. And there's also the sine wave. So we'll select sine square. and that is like the pure fundamental tone of a sine wave. It is made up of only the fundamental frequency and no harmonics, and that's why it sounds so pure like that. The sawtooth wave, to go back for a moment and get technical, is made up of the fundamental frequency plus the harmonics at full integer levels. So 100 hertz, 200 hertz, 300 hertz, decreasing in amplitude as you move up in that harmonic spectrum. And that's what gives it that rich sound to your ear. It sounds full because all of those harmonic frequencies are applied. So now back to our sine wave. You can hear that pure honey tone like that. That's just that fundamental frequency. And now we can hear how in the sine square selection, we can morph between sine wave, square wave. Okay, so we covered sawtooth, square, sine, and the last basic waveform is a triangle wave. So we'll move our position knob to the right. The triangle wave sort of sounds like a mix between the sine and the sawtooth wave, and that's because that is sort of where it is located in the harmonic makeup of the sound. Triangle wave looks like a bunch of little pyramids lined up next to each other. So it has that sort of ringing sound, but it still has that fuzz and a little bit of that pureness of the sine wave. So it's really good to familiarize yourself with these different waveforms in order to generate the sounds that you want to generate, because they all start right here at the wavetable selection. So there's a lot of possibilities in here, but it's better to just start with the basics to get to know what these sine, saw, square, triangle waves sound like. And soon you'll be able to hear a song on the radio, and you'll be able to tell, oh, that started off as a square wave, or that started off as a sawtooth wave. And that's pretty cool to be able to tell that. Okay, so that is our wavetable selection. But I should also mention that there are some of these other options in here. You have the analog electric wavetables. You have these digital ones over here, like weird stuff, like duck organ. So there's a ton of options. Yeah, you even have the chords, like this. So, there's plenty to go through, but personally I stick with just the basics. The polysaws are kind of cool too. Just keep it basic for now, because we're learning sound design, and we want to have a really good understanding of how the basic waves work before we move on to some of the crazier ones. But we'll talk about those as we build some sounds later on in the course. So what else is going on here in the oscillator section? We have a pitch box here on the left. You can see it can be adjusted by semitones, which are half steps. On a piano keyboard, it would be going up one step at a time. So 12 semitones equals one full octave. You can also adjust what are called cents. There are 100 cents in each semitone. And that's cool when you're using multiple oscillators together. You can pitch them differently by subtle amounts, and it'll create a huge detuned sound. So you can double-click this pitch box to return it to 0. And you can also adjust the pitch number using your mouse wheel. Underneath the pitch box, we have 2 modulation targets. We're not going to worry about those just yet, but we'll get to that later. Next to the drop-down menu for the wavetable is the oscillator mode. So what is the oscillator mode? It's a little bit heady, but we'll get through it. So there are 3 forms, well, really 5. Spectrum, 3 bend modes, and a formant mode. These determine what this intensity knob in the middle is controlling. So the default is spectrum mode. When you are in spectrum mode, this middle knob here reduces the higher frequency harmonics. So with the sawtooth waveform, you have a lot of harmonics, and if we drop this knob down, you'll hear it reducing those higher frequencies. So when I pull it all the way down, it sounds almost like a sine wave because it's got really just that fundamental frequency. So that's how the spectrum mode works. That's the default mode. It sounds almost like a low-pass filter cutoff. The bend mode, however, there are 3 of them. There's bend plus, bend minus and plus, and bend minus. These 3 oscillator modes adjust the shape of the wave as it goes over the course of its cycle. So what am I talking about? For example, if I have the bend plus and minus mode selected, then my intensity knob is controlling the concentration of the wave in portions of its cycle. So if I have this knob all the way to the left, this means that the waveform goes fast at the beginning and then slows down at the end of the cycle. If I turn it all the way to the right, it compresses the wave in the middle of its cycle, but slows it down at the end of the cycle. And then when it's in the middle position, or in the top, the readout of the wave is unaltered. It just goes nicely over time. So you're probably not going to be dealing too much with these in this course, but it's good to know what's happening with those. In the formant mode, the intensity knob will control the transposition of the waveform formants. So what does that mean? Well, a formant is basically a peak in the frequency spectrum. You can think of it practically as sort of sounding like a changing of vowels in speech. So this intensity knob will control the phase of the oscillator. So you can hear it sounding like almost like a phaser guitar pedal. It maintains the pitch of the oscillator, that fundamental pitch. But way at the top, you can barely hear that fundamental, and you hear all those screeching harmonics. So just as an example of what you can do with this, you can select one of these speech wavetables, like this one. And you can hear how that sounds like morphing vowels, because the pitch is the same, but the expression is different. So you're just transposing those peaks in the frequency spectrum. So those are the different oscillator modes. Like I said, it's a little bit heady, but it's good to have a basic understanding of what's going on there, and you can use that to your advantage. And really with all of these things, it's just about tweaking knobs and finding what sounds cool to your ear. That's a good principle to abide by. The last knob over here on the right is the amplitude knob. This quite simply controls the output volume of the oscillator. So if it's all the way at the top, it's full volume, and then it just gets quieter when you're turning it. That's convenient to have when you're blending, more than one oscillator. That way you can adjust the amplitude to create a good mix of your 3 oscillators. So all three of the oscillators are exactly the same, so that's good. So you know oscillator 1, now you know oscillator 2 and 3. But one other thing to mention is the filter fader here on the right. At the top, this oscillator signal is going straight to filter 1 and only filter 1. You can see this F1 at the top of the fader. That means I'm sending it only to filter 1. When it's at the bottom, it's going straight and only to filter 2. So naturally, as you might imagine, you can create a blend between the two by having this fader somewhere in the middle. Something to remember is how the filters are routed, whether in serial or parallel, but we'll talk more about what happens with that later on. So you can double click this fader to return to center as well. And so that's the oscillator. Not too bad. And next we'll talk about the modulation oscillator. See you there.